Pause the video, giving yourself plenty of time to work through this question first. Okay, so the first thing we do, we run f on A, then on 0, and on 7. And when we do that, we let m equal 0 plus 7 divided by 2, 3.5, so that becomes 3. We ask, is A of 3, which is 4, 0, 1, 2, 3, no, sorry, it's 5, same thing, which is greater than m. So now we're going to run f on the array. I stays as it was, so that was 0, and then m was 3. So that's our first execution call. Now, when we run this one, 0 is not equal to 3. So we do 0 plus 3, which is 3, divided by 2, round it down is 1. So we have m equals 1. We consider a of 1. A of 1 is 0. So a of 1 is less than 1. So we're dealing with this first part here. And so now we're going to run f on the array 2 to 3. That's our second call. 3 plus 2 equals 5. Divide by 2, round it down, we get m equals 2. We have a of 2, so 0, 1, 2 is 4, which is greater than 2. So again, we're on the second bit, and we're going to run f on the array. I was 2, and m was 2. That's our next call. And now we say if I equals j, which it does, and ai is not equal to I, well, a of 2 is 0, 1, 2, which is not equal, and so we output -1 here. So our call tree is this bit here, 1, 2, 3, 4, or the tree representing the execution path. Now, what does this give us overall? It's worth now looking back at what we did. We started out by going from 0 to 7, and then we went from 0 to 3, and then we went from 2 to 3, and then we ended up on just running on 2. So we've zoomed in on one number, and then what happened at the very end? We outputted -1 because this was not equal to a of 2 was not equal to 2. Had it been equal, so we'd then be on the output down here, and we would have outputted m. So that would be where a of 2 equals 2, or more generally, a of m equals m. And so what this is doing is searching through for an item where the index in the array is equal to the value of that array. And if it finds that, it will output the index and obviously then the value. If it doesn't, it outputs -1. Why does that work? Well, the array is sorted. So first off, I did 0 to 7. I went 0, 1, 2, 3. Now, if 5 is bigger than 3, it means the answer can't be any higher than that because all of these numbers must be greater than 5. So it's going to be somewhere down here. And then it works in the opposite direction. When we choose when we find out that a of 1 is less than 0, we have to bring that lower limit up a little bit. Okay, bit of a casual explanation. And you might be thinking, well, what if I tried to make one of these equal to the number it needs to be? It doesn't work because the numbers need to be the way they're sorted in increasing order. Okay, again with this question, I think doing the call tree is just a matter of sort of grunt work and watching out for accuracy. That last mark is quite tough to get.